This is our fourth lesson for Level 1, Chapter 1, Section 6. We will be talking about angles and how to measure angles. We're going to be primarily looking at definitions. We will not be getting into using a compass to measure the angles, but it is important that you have a compass and bring to class. As some of you start to work on the problem of the level, there will be time that we need to measure an angle with a compass. For today, though, we're going to look at the definitions. First of all, the definition of an angle is that an angle is formed by two rays with the same endpoint. We call this endpoint a vertex. So, here are some examples of angles. Here is our common vertex, point A, and a ray going in one direction, and then another ray going in a different direction. Two rays. Here are two rays going in different directions, forming an angle. And then here's another set. These three examples are meant to show us the three different ways we can name an angle. We could say angle A. Now, I prefer using this symbol, but it was not able to be done on the computer, so that we don't confuse that with the letter L. I'm allowed to call this angle A because there is no other angle there. Everyone would know what I am talking about. I can call this one angle 1 because that is the only angle out there with the number 1 on it. Here is the angle POW. The middle letter O is always the vertex. I'll say this again. The middle letter is always the vertex. It kind of implies start at P, go through O, go over to W. This becomes the most common way for us to name angles due to this picture. Point A, point B, point C, point D. At this point, there are three angles in this picture. There are not just two angles. And even if there were, if I said angle B, you would not know which one we're talking about. There is angle ABC. There is angle CBD. And there is also angle ABD. So this is important to understand why we have this third and most critical way to name angles. This way will make it so that we are very clear as to exactly what angle we are all referring to. Notice the B is always the middle letter. That defines the vertex. Next up, how do we classify angles? What do we know about different types of angles? This should be reviewed. First of all, you have an acute angle, the first example, in which an acute angle is any angle from 0 to 90 degrees, has to be greater than 0, less than 90. A right angle is any angle that measures exactly 90 degrees. An obtuse angle is one that is greater than 90 degrees, but it does have to be less than 180. And finally, we have a straight angle, which is an angle that is an angle that is equal to 180 degrees. There are angles beyond, like for example, this one out here. And we call that a reflex angle. And we'll discuss those more later. For now, these are our four general types of angles that we'll work with. Now, we learned the segment addition postulate in the previous video lesson. Here we have the angle addition postulate. It still comes down to the same thing. Part plus part equals whole. Now, from a geometric standpoint, the words are a little tough. It says if point B is in the interior of angle AOC, here's angle AOC, and point B is somewhere between that angle, then the measure of angle AOB, say this was 70 degrees, plus the measure of angle BOC, if this was 40 degrees, we could then say 70 degrees plus 40 degrees equals 110 degrees for measure of angle AOC. Part plus part equals the whole. Now, there are some corollaries to this, things that we could just jump to. For example, if we happen to see a straight angle, we don't necessarily need to write that it equals the measure of angle AOC. We can replace the measure of angle AOC with 180 degrees. Now, we have to be a little bit careful here because we must have evidence that it is a straight angle. We must either be told or have some way to show that AC is a straight line. If that is the case, then angle AOC can be substituted with 180 degrees. Now here's a sample problem that you could do in your head. You could pause the video if you need to for a second. But if the measure of angle TOP was 50 degrees and the measure of angle TOY is 125 degrees, what's the measure of angle POY? This is a slightly unique angle addition problem because I gave you a part and the whole. So we say part plus part equals whole. Well, then that must mean if you take the whole and subtract one part, you get the other part. 125, subtract the 50, and you're left with the 75 remaining for angle POY. Hopefully we all understood that and were able to figure that out. Now we have a couple angle pairs. Basically, we're looking at just definitions here. We may discuss a little bit how to use these later. First, a very important angle, vertical angles. Vertical angles are two angles formed by opposite rays. But most importantly, vertical angles have a visual definition. Angle 1 and 2 are vertical angles. They are across from each other. I want everyone writing down that they are across from each other, because that's how we recognize vertical angles. So, two angles whose sides are opposite rays does not help us a lot. Two angles who are across from each other in an intersection, that helps. Two angles across from each other in an intersection. You may want to write down angle 1 and angle 2 are vertical angles, 3 and 4 are vertical angles. Two examples. Next up is adjacent angles. Adjacent, a word that means next to. So these two angles are next to each other. Angle 1 and angle 2 are next to each other. 3 and 4 are next to each other. And we describe next to each other because they actually share something. Angle 1 shares this ray with angle 2. Angle 3 shares this ray with angle 4. They must share a ray. Two coplanar angles, important that they're on the same plane, sharing a common side and a common vertex, but no common interior point, so nothing common in the middle. So everything in angle 1 is itself, everything in angle 2 is all itself, but they do share a common vertex and side. Across from, next to. Vertical is across, adjacent, next to. Can vertical angles ever be adjacent angles? No. Then we have the word complementary and supplementary. Complementary angles are two angles, the sum of whose measure is 90 degrees. Now, I have a little bit of a mistake on this slide that I hope to be able to fix with the pens. 40 degrees and 50 degrees add up to 90. Those are complementary angles. But in this picture, I have angle 1 and 2 meant to be complementary angles. Yet there is no evidence on the board right now that they actually add up to 90. Currently, they're just another example of adjacent angles. Now, we have not been introduced to this box, this symbol yet, so now is a good time. That symbol is the symbol for a right angle. Okay, I forgot to mention it on the previous slide. That symbol right there allows us to see that it is a 90-degree angle, a right angle. Now they are complementary. The primary difference between these examples, however, is that complementary angles sometimes are adjacent, sometimes they're not. Remember, we talked about how to address a sometimes in that you show both cases. Supplementary angles, the sum is 180 degrees, or together they would form a straight line. angles 3 and 4 form a straight line. They are supplementary adjacent angles. 75 and 105 add up to 180 degrees. These are supplementary non-adjacent angles. And that is it for this lesson. There is only one other part that we're going to do, which is involving examples that revolve around that angle addition and supplementary and complementary. And I'll do those examples over on the sideboard. To wrap up the lesson about angles, I'd like to go through one example where we can touch on a few of the symbols and things that we need to know when we read problems that are algebraic based around angle addition postulate and the measurement of angles. In this problem, you are going to see a couple things that we haven't seen so far. One, a marking that looks like this. That marking is telling us that measure of angle AOB, or sorry, not measure, but angle AOB is congruent to angle COD. Now, congruent angles have equal measure. Just like congruent segments have equal length, congruent angles have equal measure. So, therefore, our conclusion is the measure of angle AOB is exactly the same as the measure of angle COD. So when I look down and I see that the measure of angle AOB is 25, I now know that what they're trying to tell me is that the measure of angle COD is also 25. The other symbol is that I've started to write up a little M in front of the angle symbol. That stands for the word measure. When you're talking about the measure, the actual number of degrees, we put the little M. Notice we do not put the M when talking about the name of the angle, just this angle is congruent to that angle and that angle over there. No M. M only refers to a number, and numbers are equal, not congruent. So, with all this information now written up, our goal was to find the measure of angle AOD. Now, using the angle addition postulate, I can say the measure of angle AOB plus the measure of angle BOC plus the measure of angle COD equals the measure of angle AOD. This is more than just part plus part equals whole. It's three parts that equal the whole. Part plus part plus part equals the whole. At this point, with substitution, 25 degrees for the measure of angle AOB, 52 degrees for BOC, and another 25 as established here for the measure of angle COD, we can now put this together as 102 degrees is equal to the measure of angle AOD. There are plenty of problems like this on the homework that you will have to piece your way through. This was the final example for Chapter 1, Section 6.